There will be 4 questions on the final exam covering sampling methods, okay? And there are 4 sampling methods. SRS, which is simple random sampling. There's stratified sampling. Cluster sampling. And systematic sampling. So you will need to know each of these sampling methods. Okay, so let's talk about simple random sampling. Simple random sampling involves having a list of everyone and then selecting people randomly from that list. Okay, so you have something called a sampling frame. Which ideally is a list of everyone. Everyone. In the population. If your sampling frame does not have everyone in the population, then your simple random sample will not truly be representative of the population. Okay? So the quality of your sampling frame will determine the quality of your sample. And so once you have a sampling frame, you select people at random, one at a time. Okay. Simple random sample. Stratified sampling is a little different. Here, your population has subgroups, and the subgroups are defined by a common trait. Okay? Subgroups called strata, like layers. Okay, and each subgroup has some kind of common trait. So things like You might have subgroups determined by gender, or you might have subgroups determined by race, or subgroups determined by some other variable, okay? Another common trait. Each subgroup has a common trait, and there, we know the proportions of each subgroup in the population. When we pick our sample, which is done similarly to simple random sampling, when we pick our sample, we make sure that each subgroup is represented with the correct proportion. So if the population is 50% male and 50% female, we'll make sure that our samples are 50% male and 50% female. If our population, if we're talking about, I don't know, some kind of knitting club, then the population is probably going to be like 90% female and 10% male or something, okay? When you take your sample, you want to make sure your sample is 90% female and 10% male. Okay? So that would be stratified sample.
Could you give us an example of how many might give us using?
Okay, all right. We'll get to that after I cover all the sampling methods first. All right. Is that okay also? All right, let's talk about cluster sampling and systematic sampling. Cluster sampling. This is done when it is very difficult to get a list of everyone in the population, but easier to get a list of clusters that should cover everyone. Okay? So the population is divided into clusters, and it's easy to get a list of all the clusters. Do is we randomly select clusters and survey everyone within the cluster, or do simple random sampling within the cluster. Last method systematic sampling. This works best if there is a line or queue. And then we select every 10 or 7 or just n person in line. Okay. So, let's, I will describe situations. So these are the types of problems you might see on the exam. But I'll just speak them out loud, and you can tell me which sampling method it is. Okay, so don't shout out the answer. Just listen and think. Okay. Okay, so a school has a high school has 9th graders, 10th graders, 11th graders, and 12th graders. Okay. Each grade makes up about 1/4 of the school. You take a random sample of 400 students, and you make sure that 100 are freshmen, or 100 are in 9th grade, 100 are in 10th grade, 100 are in 11th grade, and 100 are in 12th grade. What sampling method is that? Don't shout it out. Think of it. So once again, high school has 4 grades, 9th, 10th, 11th, and 12th. Each grade has about 25%. We're taking a random sample of 400 people, and within our sample we have 100 9th graders, 100 10th, 100 11th, and 100 12th. Okay, what sampling method is this? Stratified sampling. Okay, we know the proportions in the population, and we select our sample to match those appropriate proportions. Okay. You have, here's another one. Okay. A customer service center wants to get take surveys of their customers. So it decides every 5th caller that calls in gets routed to a separate line that forces the customer to take a survey. What kind of sampling is that? Okay, and the answer is systematic sampling. Okay, because it's sending every such and such person, so every 5th person gets sent around. All right. In Los Angeles County, we want to take a random sample of people who go to church. So we instead of getting a list of everyone who goes to church, we take a list of all the churches in LA. We randomly select 35 of those churches, and we survey everyone in each of those churches. That would be
Cluster
sampling. Okay. Alright. Okay. Well, I'll give you an example of simple random sampling. Maybe we go back to the high school. The high school has students in 9th, 10th, 11th, and 12th grade. We get a roster from the registrar, and we randomly select 200 students from the student roster. That would be simple random sampling, because In that example, we're just selecting them from the list of all the students. Okay, is that alright? So, in my opinion, these questions are easy on the final exam. I just kind of described 4 different scenarios. And you tell me whether it's simple random sampling, stratified cluster, or systematic.
That's 8 points.
That's, yeah, 8.8 points right there. Okay.
Are they all in the same area on a
Yeah, they're all together right there in the same area. Okay?
cluster?
But I'm always amazed at how many students miss those questions. Okay. Students are packing up already. So, what is it? 8:48. Okay. So technically, there's still 40 minutes of class. I want to start review and start going over some stuff. If you don't want to stick around, you don't have to stick around. But I'm going to take this time to start doing some review.
Are you
And,
going to repeat the review tomorrow?
I will not. Tomorrow I will be going over all of the answers to the practice final. Okay? So that's a review in of itself. And this I'm going to do kind of just more of a generalized, here are some things to keep in mind. Yes?
What chapter was this? Where did I find
This is in chapter 12. Okay? And I will modify this week's homework. There's no homework due next week, okay? Or the final, just chapter 12 will be optional. I'll just give everybody credit for this last homework. I'll say everybody did it, and which is pretty much what I feel like I've been doing, because everyone just has been turning those papers saying I did it. So.
We have like one more homework chapter extra points.
Extra points, extra
Uh,
points.
no, there's no. I mean, there's no. There's
Not
no
like
point,
extra
right?
credit, just like
I've given you so many opportunities for extra credit on your quizzes and tests. I feel like.
not extra credit, not like extra like to dilute out. Don't listen to that. I want to dilute out everything else.
Okay. I want to maintain the integrity of my course, so I will not succumb to student demands. Okay, on the website, there's something that says that says about the final exam, and on that page there is a study guide. Okay, and in my opinion, that study guide is quite useful. And if you want to use the study guide as your note sheet for the final exam, that's fine. And then there's some spaces where you can write and fill in even more notes if you want. But basically, the most important thing for any of these problems, number one thing is identify what type of problem you are dealing with. So you gotta identify what type of problem you are dealing with, and that is the most important thing, because if you mess this part up, the rest of your problem is gonna be bad, okay? And so, we have proportions with one sample, and it could be either a confidence interval or a hypothesis test. And then we have proportions with 2 samples. And that is going to just be a hypothesis test. Then you have problems dealing with means with 1 sample. That's going to be confidence interval or hypothesis test. And then you have problems dealing with means with 2 samples. Again, you can have a confidence interval or we're dealing with proportions, or how do we know when we're dealing with means? Okay. If you have categorical variables, there will be proportions. Other key things is as you're reading and it talks about a proportion or percentage, if you see proportion or percentage, 99% of the time you're dealing with proportions. If you have counts, if your data only has counts, counts of people or items, then you're dealing with proportions. Okay. On the other hand, if you have a numeric variable, you will be dealing with means. Okay, you see words like average, or the mean. In your problem, you're dealing with means, okay? If your data has a standard deviation, you're dealing with means. Okay? Don't mess this up. Alright, do you have one sample or two samples? Okay. Sometimes as you're reading a problem, you think you have two samples, but you only have one, okay? You can only have two samples if you can identify two different ends. Okay, if you can identify an N1 and then identify a separate N2, then you have two samples. If you can only identify one N, you only have one sample. Okay? So in order to have two samples, possible that both N1 and N2 have the same value. You might have a sample of 25 and another sample of 25, but you still have two N's. Okay? So just make sure you can identify how many N's you have. Okay? And then the problem will say whether you are dealing with a confidence interval or a hypothesis test. Okay? As you're reading the problem, if you see the word hypothesis, you're dealing with a hypothesis test. If it says make an interval, you're dealing with a confidence interval. That part is straightforward. However, it's probably useful to highlight or circle the word interval or highlight or circle the word hypothesis test or something, because all of the formulas, a lot of the steps will be different based on whether it's a confidence interval or a hypothesis test. And if you yourself get mixed up on that, you will run into problems, okay? So just recognize you have a confidence interval or a hypothesis test. So let's cover the scenarios with confidence intervals first. again, the different scenarios for confidence intervals, you have proportions, one sample. Okay. We never learned confidence intervals for two samples. Okay, they do exist, but we never learned them, so you will not be tested on it. Okay, we have confidence intervals for means with one sample, and confidence intervals for means with two samples. Actually, I should probably tell you on your sheet, orient it sideways and then make these three columns or something. Well, I don't know. However you want to do it, okay? I'm going to just talk about each of these. Alright. Proportions. P hat plus or minus Z star times the standard error P hat 1 minus P hat over n. Means one sample. The confidence interval is x bar plus or minus T star times S divided by the square root of n. In means of two samples, x bar 1 minus x bar 2 plus or minus T star times S1 squared over N1 S2 squared over N2. Okay, those are the confidence intervals, the formulas for each of these confidence intervals. It might ask you questions like, what is the center? The center of a confidence interval is P hat. Center is always the part that comes before the plus or minus. This is the center. This is the center. This right here, thing with the star, that's always called our critical value. And then the term that it's multiplied by, that's the standard error. If you take the critical value times the standard error, that's called the margin of error. Okay? So if you take these two things, this is known as the margin of error. Okay, so if we ask the margin of error over here, this, and it's this part over here. But so that's just labeling the parts of the standard error. Okay. One thing to note, confidence intervals, the standard error here uses p hats, okay? Use p hat, do not use p for confidence intervals. Where do we get Z star? Yeah, there's four numbers that you need to know that you should have written down on your card or have memorized, right? 80%, 1.28. 90%, 1.645, 95%, 1.96, 99%, 2.58, okay? So the Z star just has the list, okay? Z star is 1.28, 1.645, 1.96, or 2.58, depending on this problem. This is for 80%, 90%, 95%, or 99%, okay? That's how we just determine Z star. Okay, critical value for means of one sample, the T star, degrees of freedom is equal to n minus 1, always round down, pick the appropriate column. It says confidence level this, choose that level or column. Okay, what about over here? How do we get our degrees of freedom for two samples means? Yeah, we also use n minus 1, but we have two n's. So what do? We use the smaller n, okay? Use the smaller n. Alright, is that okay? Alright, and then if we ask, does the confidence interval provide evidence that it's different from some number? Different from 2? What are you looking for? Okay, so alright, here's a good. Well, first of all, if I say, does the confidence interval provide evidence that that the mean is different from 2, which confidence interval are we talking about? Proportion one sample, mean one sample, means two samples.
2.
Mean one sample, this one, okay? Over here, means of two samples, it would say, does the confidence interval provide evidence of? It'd say, does the confidence provide evidence of a difference between the means? Okay? So maybe I'll write that down, okay? Does it provide, does CI provide evidence of a difference between means, okay? This one would be, does the confidence interval provide evidence that the mean is not some number? This one would say, does the confidence interval provide evidence that the proportion is not blank, okay? And how do we answer these questions? Or how do we decide that it does or does not provide evidence that it's not some number?
Oh, we say we're 95% sure that such and such.
Okay. So if my intervals over here says it goes from 10% to 15%, and I ask, does it provide evidence that it's not 12%? What would you say? No, it does not provide evidence. And why doesn't it provide evidence? Because 12 is inside my interval, okay? So if this number is inside your interval, it does not provide evidence. What about over here? Does my confidence interval provide evidence of a difference between means? Let's say my confidence interval goes from 1.3 to 3.7. My confidence interval for the difference between means goes from 1.3 to 3.7. Does that provide evidence of a difference? Yes, it does. And why does it provide evidence? Because over here, we're looking for 0. Okay? So in these two ones, it will say, does it provide evidence that it's not some number? And you're looking to see if that some number is within your interval. This one, if it's asking, is there evidence of a difference between means? It doesn't give you that some number to look for. But that means you are looking for 0. So in this scenario, you are looking to see if 0 is in your interval. And over here, you're looking for that some number. Alright, let's talk about hypothesis tests. Okay, so here we have proportions. One sample. Now we have proportions 2 samples. We have means, 1 sample, and means 2 sample. 2 samples. In each of these, you're going to be asked, what are the hypotheses? So your hypothesis for proportions 1 sample is going to be P is equal to some number, and I'm just going to make up some number, 28%. Okay? That means in the problem we're saying, do we have evidence that it's not 28%? The alternative, P does not equal 28%. Or maybe it's greater than 28, or maybe less than, okay? Okay, depending on how the question is written. Standard error. Square root of P times 1 minus P over N. And your test statistic is a z-score, and that's P hat minus P over the standard error. Once you get your z-score, you look up in the z-table to get your tail area, which you use to find your p-value. Is that okay? Can I move on? Alright. Proportions of 2 samples. Null hypothesis will always be P1 equals P2, or it'll be written as P1 minus P2 equals 0. Be prepared to see either form of those on the The alternative, P1 doesn't equal P2, or P1 minus P2 doesn't equal 0. And again, you can have or greater than or less than, depending on how the problem is written. You got to figure out this p hat, which is going to be x1 plus x2 over n1 plus n2. Figure that out, and then you can get your standard error, which is p hat times 1 minus p hat 1 over n1 plus 1 over n2. Your test statistic is a z-score. P1 hat minus P2 hat. Technically, there's a minus 0 divided by the standard error. Look this up. In the z-table to get your tail area. And then find p-value.
Z is our test statistic, right?
Yeah,
Okay.
z is your test statistic.
Thank you.
Yeah. Yes.
And then, after we find the p-value, we have to multiply by 2 for the two samples.
Yes, to find the p-value, I was going to write that all up, just things that apply to all hypothesis tests. If you have a one-sided test, your tail area will be your p-value. If you have a two-sided test, you double your tail area to get your p-value. Alright, means of one sample. Your null hypothesis is that the mean is equal to some number, 32, and then the alternative is that the mean is not that number, or it's greater than or is less than. Your standard error, s over the square root of n. Your test statistic is going to be x bar minus the mean given in your null hypothesis mu divided by standard error. Look, use degrees of freedom equal to n minus 1, and look this up in the t-table. And find your tail area and find your p-value. Okay, and means of two samples. Mu1 equals mu2, or can also be written as mu1 minus mu2 equals 0. The alternative, mu1 doesn't equal mu2, or alright, the observed difference x bar 1 minus x bar 2. Your standard error their difference, x bar 1 minus x bar 2, technically minus 0 divided by standard error. Look that up in the t-table. To get the tail area. And find the p. Is that okay? Alright, and then let me just put a few other notes regarding all hypothesis tests. If the alternative hypothesis has not equal, then we'll have a two-sided test. So our p-value is equal to 2 times our tail area. If the p-value is less than alpha, our significance level, then we reject the null hypothesis. Let's say we have evidence that the alternative is true. Whatever it says. On the other hand, if the p-value is greater than alpha, do not reject the null hypothesis. And we do not have evidence. To say that the null hypothesis is wrong. You guys remember what a type 1 error is?
I have a quick question.
Yeah.
Are those three sentences over there, do they correspond to any of the 4 categories? Or
They apply to all hypothesis tests.
Thanks.
All hypothesis tests. So this board applies to all hypothesis tests. The type 1 error and the type 2 error stuff also applies to all hypothesis tests. Do you guys remember what type 1 error is? So this is, we mistakenly reject the null hypothesis when the null hypothesis is actually true. The probability of a type 1 error is equal to alpha. We talked about this, right? Or is this completely completely new?
Yeah, I think
I've-
I've read it.
I've never mentioned this?
You mentioned it, but then I don't think we went over it.
Okay. Okay, so if at the end of the problem you've rejected the null hypothesis, but that happens to be wrong, that decision to reject the null hypothesis happens to be wrong, you've made a type 1 error. Did you do anything wrong, per se? No. You followed the steps following all of your data. But if your data for some reason leads you to reject the null hypothesis, but the null hypothesis was actually true, that's called a type 1 error. So sometimes based on the evidence you have, you make this decision, but then it turns out that was the wrong decision. Okay? And if that happens, and your decision was to reject, that's a type 1 error. On the other hand, okay, just type 2 error, on the other hand, is we do not reject the null hypothesis. Okay? But our decision not to reject was wrong. Probability of a type 2 error is equal to beta. And 1 minus beta is equal to something called power. So this is a freebie that I will give you guys here. Somewhere on the test there's a question that says, what is 1 minus beta? Say this is power.
Alright, I'm at 10 points.
Okay. Great. And maybe that email says to pass you only need 10 points.
That would be...
Who knows? Who knows? I don't know what it's like.
I don't think that's going to be the case.
Alright, maybe not. Okay, so in the practice final, there will be a question that says, is this a type 1 or type 2 error? Okay? You just have to ask yourself, did I just reject the null hypothesis? If you did, and that was a mistake, that's a type 1 error. If you said, no, I just chose not to reject the null hypothesis. Okay, if you didn't reject the null hypothesis, and that decision turned out to be a mistake, that's a type 2 error. Okay?
How should we know if it's a mistake or it's not?
Only later. So in real life, you make decisions and you don't know if it was the right one or the wrong one until much later, right? You marry someone and you're thinking, I hope I married the right person. And it might turn out, oh no, that, oh well, you know. So this is what happens, you know. In the test, I can say, it turns out that, you know, your decision was a mistake, okay? But in real life, you make a decision. It's like you market this drug, and you say this works, and then it turns out it doesn't, and then you get a class action lawsuit, okay? Sometimes things like that happen. And that only really happens after more data, okay? That's actually very much illustrative.
I would have been better on the quiz if we had this guy. This is phenomenal.
Okay, so this is an outline. So tomorrow during the review session, I'm just going over all of the answers to the practice final. The practice final is longer than the actual final, so you get extra practice, okay?
When you gonna post the video then?
As soon as I can, I guess. All right. Okay, so some of you, I'll see you guys tomorrow. Great.